Today we're going to look at finding the equation of a line using 2 points. We'll walk through a clear example, step by step, and look at different approaches you can take for finding the equation of this line. And we'll end with a similar problem so you can practice these skills on your own. So let's get started. So for this example, we're told that a line passes through the points -3, 2 and 9, 10. And we're asked to write an equation for the line in slope-intercept form. Now for this example, I'm going to show 3 different ways of finding the value of the slope, but you only need to find it one way. You can choose which method you like to use. You have options. You only have to pick one of those methods. And then when we write the actual equation, I'll show you 2 different ways of finding the equation. But again, each time, you only have to pick one of those. You may prefer one over the other, or maybe one method works better in some situations than the other method. Again, it's your choice. Unless, of course, somebody's telling you to solve it in a very specific way. And then just do what that person tells you to do. So we're given 2 points that are on this line. Now to solve this problem, there is no need to graph anything. But let's take a quick look to see what we're doing. Let's graph these 2 points. Again, to solve this problem, you do not need to graph these points, but I'm going to go ahead and plot these so we can see the line that we're going to write an equation for. So we have -3, 2, and then we have the ordered pair 9, 10. So we have our 2 points on our 2-dimensional xy plane, so we can connect these points to show our line. So our goal is to write an equation for this line. And to do this, the first thing we want to do is find the slope of this line. How does this line change as it moves from left to right? So there's a couple different methods we can take to finding slope. What I typically do is I will plug these x and y coordinates into this formula for the slope. So we have the slope equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. It does not matter which of these ordered pairs you choose to be point 2 and point 1. What matters is if you say 10 will be y sub 2, its corresponding x coordinate, in this case 9, has to be x of 2. So your y and x coordinates have to come from the same point. So I will use a y sub 2 of 10, and then I'll go ahead and write my x of 2 value as 9. And then I'm going to draw these minus signs because we're subtracting. And then y sub 1 is 2. And x of 1 is -3. 10 minus 2 is 8. This is 9 minus a -3, so this is 9 plus 3. We now have 8 over 12, and this simplifies down to 2/3. So we now have our slope. Again, this is one way of finding the slope of this line, but it's not the only way. Another way you can find the slope is you can go ahead and make a table of values. So we'll make an xy table. We have an x value of -3, and its corresponding y value is 2. And then an x value of 9 with a corresponding y value of 10. And then from here, we can look at the difference between the 2 x coordinates and between the 2 y coordinates. So as we went from -3 to 9, well, that's an increase of 12. And as we went from 2 to 10, that's an increase of 8. Again, we're still looking at that change in y over the change in x. So this is a change of y, which was 8. The change of x was 12. This is 2/3. We have that same value. And then a third method for finding the slope is to actually count the change on the graph itself. Again, if you use this method, you will need to graph these points. So this may take a little bit longer to do. You can start at either point. I'll go ahead and start at the leftmost point. And we're going to count 1, 2, 3, 4, 5, 6, 7, 8. So our change in y was equal to 8. And then starting at that same point, let's count our change in x. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our change in x value is equal to 12. So we have our change in y over change in x. That's our slope. It is 8 over 12. And this simplifies down to 2/3. So all we've done so far is find the slope. And I used 3 different methods to do it. And regardless of the method you do, you should end up with the same value. I almost always use this slope formula, unless if my values are actually given in a table form. So now that we have our slope value, we have a slope of 2/3. Let's write this equation. And to write an equation, we need the slope of the line, and we need a point that's on that line. We have our slope, and we started with 2 points. And now let's look at 2 common approaches for writing this equation. Now I learned using this formula, and this formula is called the point-slope form, because you need a point and a slope to write this equation. And this has always been my go-to form for writing equations. However, you can also use our tried and true friend, the slope-intercept form. But let's start with point-slope form. So with this point-slope form, we're going to plug our value for slope, m, into the equation, as well as the x and y coordinate values for one of those points. It doesn't matter which point you pick. I'm going to choose -3, 2. So this is y minus, so y sub 1 is 2, equal to, we have a slope of 2/3, x minus, and then our x coordinate value is -3. This is y minus 2 equal to 2/3 x plus 3. Now one thing to consider when choosing which point to pick is I knew I had a fraction for a slope, and I would eventually need to multiply 2/3 and my x coordinate. I took a look at both of my x coordinates. Both of them are divisible by 3. So I knew when I multiplied this out, when I did that distributive property, I would not have a fraction. So that's one thing to consider when choosing which point to pick. We now have an equation for this line in point-slope form, but let's go ahead and write this in slope-intercept form. And we typically write equations in either slope-intercept form or standard form, and not point-slope form, because every point that's on this line is going to have a unique equation for point-slope form. So it becomes difficult to compare whether or not 2 equations represent the same line. But when we write it into slope-intercept form, all of these different point-slope forms will have the same slope-intercept form. So this is y minus 2 equal to 2/3 x plus 2/3 times 3. This is 2. And then we'll add 2 to both sides. And we have y equal to 2/3 x plus 4. And this is our answer. This is the equation of the line in slope-intercept form that passes through the points -3, 2, and 9, 10. Now let's look at another way of finding this equation using the slope-intercept form. Now with the slope-intercept form, we know the slope, m is still 2/3, but we do not know b. We do not know where it crosses that y-axis. Neither of these points are the y-intercept values. We do still know a point. We know two ordered pairs, two sets of x and y coordinates that are on this line. So we can plug these values into this equation, much like we did with the point-slope form. Again, pick either point, and this time I'll pick this second point, 9, 10. But it doesn't matter which point you pick. So we have a y value of 10 equal to, our slope is 2/3, x value is 9, and we do not know b. So here, we're going to solve this equation for b. We have 10 equal to, so we're going to cancel this 3 and the 9. So we now have 2 times 3, so this is 6 plus b. Subtracting 6 from both sides, we end up with 4 equal to b. This is the same as b equal to 4. So now we know our y-intercept, and we know our slope, so we can now write this equation in slope-intercept form. Y equal to 2/3 x plus 4. Again, it's the same equation. It does not matter which method you use. I learned with the point-slope form, but using slope-intercept works just as well. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do this problem. So the first step for writing an equation when we're given 2 points is to find the slope of the line. Here are 2 methods of finding that slope. I typically use method 1, where I use that formula, the slope is equal to y sub 2 minus y sub 1, all over x of 2 minus x of 1. So the change of y over the change of x. Plugging in those values, we end up with a slope of -5/4. Another method is to create a table with the ordered pairs, and I prefer having my x values in order. So I have my smallest x value first, which is -12, and then its corresponding y value, and then the next ordered pair 4, and its corresponding y value of -7. And then as we move from point 1 to point 2, our x value increased by 16, and the y value decreased by 20. We have our slope formula, change of y over change of x. This is -20 over 16, which simplifies down to -5/4. Again, 2 different methods for finding the same thing, the slope of this line. We end up with a slope of -5/4. You only need to do one. You could have also done this with graphing by plotting these points on a graph and then counting the change directly on the graph. I showed that method in the walkthrough, but I chose not to show it here because I typically do not use that method, and also this ordered pair was not on my 10 by 10 graph. So now that we have the slope, it's time to write our equation. Again, I'm going to show 2 different methods, but you only need to do one. So for method 1, we use the point-slope method, and we plug in the value for our slope in one of our points. We simplify this down, and then we can rewrite this in slope-intercept form. For method 2, we're going to use the slope-intercept form. We're going to plug in our value for a slope and 1 point into the equation, and then solve for b. This gives us the y-intercept. Now we know the y-intercept and the slope. We can plug those values into the slope-intercept form, and again we're going to end up with y equal to negative 5/4 x minus 2. Either method works. You just need to do one of them. Drop any questions you have in the comments. Continue practicing writing an equation of a line from 2 points, and I'll see you in the next video.